This is the Earth, and that's the sun, and there's our solar system. Beyond that is the galaxy, and then our entire universe. But what about other galaxies, solar systems, and planets? Well, those planets are called exoplanets. What's an exoplanet? Well, an exoplanet is any planet that's outside of our solar system. Currently, there are 3 methods for detection, and they all focus on looking at the star that a planet orbits. First up is radial velocity. Radial velocity relies on the theory of planetary motion. This theory assumes that a star doesn't remain stationary when orbited by a planet. In the same way that a star pulls on a planet to keep it in orbit, the planet pulls on the star. From a distance, Earth, these shifts either look red when the star is pulled toward us or blue when the star is pulled away from us. Constant shifts in this color can lead us to conclude that there is a planet there. Now, this method was the first successful and reliable detection system. However, since it cannot distinguish between masses, we cannot confirm from just this method. Next is the microlensing method. This method is the most complicated. However, it can detect planets that are very far from Earth.
In this method, we have a background star and a foreground star. As the background and foreground star line up, the background star brightens. The gravitational field of the foreground star warps space to create a gravitational lens that magnifies light. If a planet is orbiting the background star, it too will gravitationally lens the background star for a short duration.
By measuring this brightness, we can determine whether there is a planet in that location. This method is very precise and useful for long distances. However, since all the information gathered is rough estimations, it cannot be used for analyzation. The third is transit photometry. In transit photometry, we measure the brightness of a star over a prolonged period of time. As a planet comes in front of a star, there will be a decrease in brightness, called the transit. Constant repetition of the transit can lead to exoplanet confirmation. This method is very sensitive and effective for exoplanet detection. There's also a lot of data to be analyzed after the Kepler launch. However, measured transit must occur several times. For example, the planet Kepler 1647b has an orbit of 27,000 years. If we wish to confirm this planet through this method, it would take us thousands of years to measure the orbit and the transit. All of these methods are quite effective at exoplanet detection in their own way. However, each has its own disadvantages. Researchers are still working to come up with new and more effective solutions. Will you be the one to find the next?